Hey guys, so let's look at the application of the exponential functions or equations. So this part, I think, is where most of the students find some challenges. Yes, because they like asking things about money as if you are studying a program under School of Business. But I'll try to okay, in this video I'll just introduce you to the things that we'll be using, like the concepts, the terminologies that you'll be hearing, the formulas that we're going to be using, because we'll be using some formulas and we'll be combining the formulas with the knowledge of the exponential functions. So let's look at what is called the compound interest. So what is compound interest? First of all, you need to understand what the word compounding means when they say compounding. So first of all, I would like to ask for your attention, because I'll try my whole level best to apply everything, like the important concept, to realistic examples. So I hope that you don't dose, because I'll give some realistic examples here. So let's imagine I have 5,000 and then I put it in my saving account, in my bank saving account, okay? And then the bank tells me that, okay, this money that you've given us to keep for you, every year it will be increasing by the percentage of 10%. So now let's say that I just want to save for I think for 3 years. Okay, for 3 years. So now for the first year, for the first whole year, what will be in my bank account after 1 year, since they have said that it will be increasing by 10%. So 10% of the same amount will be added to it. What is 10% of 5,000? So the way that you find that is by doing this. So say 10% divided by 100, that will give you 0.1, and then you say you multiply 5,000 times 0.1. That will give you how much? 500. So this 500 that you have seen here is what will be added to my bank account. So now after 1 year, I think, let me be writing here. So after 1 year, in my bank account there is going to be 5,500. How about by the end of the second year of saving in this bank account? So look, I haven't withdrawn the money because this is a savings account. I'll only be allowed to withdraw after the years that I agreed with the bank. Okay. So now in the second year, I think, let me draw a separation here. So in the second year, I'm going to start with, when going in the second year of saving, I'm going to start with how much? 5,500. So this time it is going to again increase by how much? By 10%. So I'm going to say times 0.1. So 5,500 times 0.1. This time it will give me what? 550. So 550 is going to be added now. Okay? It will be added on top of what was the initial amount. So this time I'm going to say this plus what was in the account initially. That's going to be, it's going to be 6,000. Now in the final year, now by the end of the final year, first of all, I'm going to begin with 6,500. So times 0.1, that's 605. So now 605 is going to be added here, and that is going to give me, so after 3 years, this is what I'm going to withdraw. Have you seen? So this will be the final amount. So how much profit am I going to make? You just have to subtract these two, right? So the interest rate in this case, the amount that it was increasing by, or the percentage, is what we call the interest rate. Okay, the interest is based on percentages, not fixed. So this is called the interest rate. So in this scenario, the amount that I initially saved was what? Was 5,000, right? And that is what is called the principal value. Principal value. And the amount that I finally had, that is just the final now. You can just call it the final amount. Yeah. And this percentage is the interest rate. So this is what is called compound interest. So compound interest is now the final amount. Actually, the final amount the total amount that you get after everything, after the years have passed, the year that you agreed with the bank. So this concept is actually applied like even in a business. Actually, even Albert Einstein, he once praised it. He called it the sixth wonders. Eighth wonders of the world, something like that. But he included it among the wonders of the world because this is the formula that the business people use to grow their businesses. So what happens in a business is that whenever I make a profit, like every month, put it back in a business so that it can compound, like it will add on to the initial capital, okay, and then it will make more money, and after some years you're going to increase the capital. Now this is beyond the scope of this because they won't ask you that, maybe for general purposes, but try to be applying this. It will really help you, okay. And so we now look at the formulas that we're going to be using. So let's look at the formula for compound interest. And I hope that you have understood what compound interest is. I've showed you the realistic example. Okay, so look, here's the formula for compound interest. It goes like this. A is equal to P 1 plus RT. Now, what do these mean? A means, let me write A. A is equal to compound. This is compound interest. Let me finish writing it from here. Interest. In the previous example that I showed you, the realistic one, compound interest is that amount that we eventually had after investing 5,000 for 3 years, which was increasing by 10%. I don't know if it was 6,000 and something, I can't remember. That is the compound interest, the final amount that you get, okay? So make sure that you read the question very carefully so that you can be able to recognize which one should you put here, which one was the final amount after the money was invested. And then P is the principal. It's called the principal value. This is the money that was initially invested or initially saved or initially put into anything that was compounding the money. To compound, now you know what it means, right? So maybe by definition, to compound is like to increase the money after a certain period of time by a certain percentage. That's how we can define it. I think in my own words, I think that one makes sense. So this is the principal, and R is the rate of interest. I showed you how the rate was having the influence on the money, like how it was multiplying. I don't know if I should say increasing the amount, right? And let's talk about T. So T is simply the time. So now this time, it can be in years, in days, in months, in anything, or even in seconds, because you can be compounding like every day. Every day you are making money, you are compounding, you're making more money, you're compounding if you're in a business. So it's not always like strictly years, but oftenly I've never solved the question that involves anything apart from a year. But make sure that you read carefully the question. If at all they were to say that they say daily or monthly, just know that this time it is in days or months, but oftenly it will be in years. So take note of this formula. You need to master this. They don't bring this. They won't give you this on the exam. Take note of this. You need to memorize this. Like, you need to master it, and there's no short method of memorizing. Just put it all in your head. So when they want you to use this formula in the question, they just say they'll use the word compound interest. This whole word, they'll use it. So now sometimes they won't use. I mean, there are some terminologies that they might use. Okay. There are some terminologies that they might use, and if you see, I think let me make a division. So of course I'm talking about now another thing here. So if you see in a question, they haven't used compound interest, or they haven't said that it was compounding. Okay, look, in the question, if they just say compounding, or maybe they say it was compounding yearly, but they haven't used the word that I've used below. I mean, that I'm going to write right now. Use this formula. Now, if you see any of these terminologies in the question, because I don't know how you can phrase the question, but if you see these terminologies, you need to use this formula. The formula is A is equal to P 1 plus R over N NT. Now, what are these terminologies? If you see where they have said semi-annually. Annually means yearly. Sometimes they might say annum. Maybe they might say if it was compounding per annum. Annum is written like this. It simply means a year, a period of 1 year. So make sure that if you see annum, just know, okay, this time will be in years. Very tricky. I'm showing like all the ways in which they can try to confuse you. So the other word is quarterly. Per quarter. I don't know if this is how you write the word quarterly. The other word is weekly. And then the other word is monthly. The other word is daily. So in a question, if they have used these terminologies here, just know that you use this formula. If they have said that it was compounding daily, monthly, weekly, quarterly, or semi-annually, you use this formula. So at your level, you use this for only yearly. So this one is for yearly, always yearly. If they use something else, makes sense, right? Now let's look at the formula. So this formula, it has got something which is n. So this formula is used when the money was being compounded a certain number of periods in a year, meaning that it is used if you know, like if money was being compounded like many times, more than one time in a year, within a year, it was compounded maybe like twice, maybe 3 times or 4 times. It would depend. Now in the question they won't tell you. Maybe if they told you directly, they might not use maybe semi-annually or any of these. Maybe if they say that money was it was being compounded 20 times in a year, just know that put 20 words in. Now what they like doing is that they won't tell you that this time or maybe 5 times in a year. They won't tell you that. They will just use this terminology. They say semi-annually, quarterly, weekly, or monthly. So if they say semi-annually, n will be equal to 2. It means that in a year, money was being compounded twice. Okay. And then here if they use quarterly, it means that money was being compounded 4 times within a year. If they say weekly, how many weeks are in a year? 52. So n is equal to 52. If they say money was being compounded monthly, how many months are in a year? It is 12, right? So n is equal to 12. if they say it was being compounded daily, how many days are in here? 365 days. So n will be equal to 365. So if you're using any of these terminologies, time will also be in years. Hope that makes sense. P is still the same principle, compound interest, the rate. So here the only difference from the previous formula is just the n. Are you seeing? Is simply the n. And for these formulas, time is often in years. Okay, so now listen. Let me just put everything together. So if they are saying that money was being compounded yearly, they have just said compounded yearly. It was being compounded every year. Use this formula. In case maybe you are confused, like now, which one should I use here? Which one should I use here? Use the, where is it? This one. Because these two formulas can be confusing sometimes. And if they have used any of those terminologies, use the other one. Okay? Time, if they have told you to find time, it should be in years. And then there is also another terminology. If they have said that money was being compounded continuously, like to the infinity, it has no end, it will be compounded forever. Okay, that's what it means. Like there is no limit, it will ever be compounded without stopping. That's what it means. Yeah, so you use this formula. A is equal to P E R T. T times R, rate of interest. Yeah, the initial amount invested and the compound interest. Makes sense, right? So if you see in the equation, they just use the word continuously. You use this equation. So far, I've showed you how many equations to master. 3 equations. This should be in your head because you don't know what they will bring in on the equation. They might bring this, lectures are not predictable. They are unpredictable. Let's look at the last formula, last concept actually. Don't be afraid, guys. These are very easy. You just need to know how to apply the exponential functions and the formulas. You're going to see how I'll be solving the questions. Let's talk about the exponential growth. So, before I show you the formula first, let me give you a scenario case. Let's assume that maybe some food samples, maybe let's say bread, has been infected by some bacteria. You know that bacteria, they duplicate themselves, they undergo binary fission. Let me not talk about biology here. So let's say the bread has been infected by the bacteria. Bacteria duplicate themselves. That means that if maybe it's just infected by one bacteria, this bacteria is going to duplicate itself. There's going to be more bacteria over time. Okay, so the bacteria will be increasing exponentially day by day from the day of infection, from the day the bread is infected, or from the day they are going to infect this. So maybe let's say they infect the day, this is maybe let's say day 1. The bread has been infected. And you know how the bread look like when it has been infected, right? Yeah, so let's say maybe this is day 1. Maybe this is day 2. Day 2, maybe there's going to be like maybe this amount. Maybe they'll cover like half of the bread. Maybe by day 3, the whole bread now is going to be what? Affected. The whole bread. So just to show like that, the whole bread. So have you seen the amount is just increasing as days goes on. The amount of bacteria are increasing. So let's say the initial amount when the bread was just infected, they were about maybe 10 kg. 10 kg of bacteria. On the second day, there was like okay, these are just I know 10 kgs is a lot. Okay, let me use grams because 10 kg that's now too heavy. So maybe this time 20 grams, even 20 grams is a lot. Now this is just an example, don't take it serious. Okay, so the amount is increasing, everything, and it will ever be increasing as long as the bacteria are there. This is what is called exponential growth. When the growth is exponential, it's like it is just growing forever and ever. Okay, that's what it means. That's why they say the exponential graph. When they say that the cases of corruption are increasing exponentially, just know that they are never ending. They are just increasing. They are not reducing. They're just going upwards. Yeah, so that's how it goes. So now look, you can calculate the amount of bacteria if you know the initial amount, the amount that was there the day the bread was infected. You can calculate the amount of bacteria maybe after like 5 days, or maybe after 20 seconds from the time the bread was infected. Okay, so you can calculate the amount of something provided that you know the initial amount after a certain interval, which brings us to this formula, which is Q with a time here in parentheses, and Q here, and exponent, and there is K. Now this formula, I don't know, maybe you don't need to master it, but you need to know how to use it. Like questions that involve this formula, they'll be up using the concept that I've just explained of bacteria. I've just used bacteria because it's the suitable example for this concept. Okay, so you can calculate if you know the time. Now what does it mean? So this part A is representing the amount of bacteria at a certain time, and this is representing the initial amount of bacteria that were there the initial day. And K is just representing like it's like the growth constant. It's the growth speed, like at what speed were the amount increasing, the amount of something is increasing. And then time is simply the time. Let's say you want to find after the amount of bacteria, let's say after 5 days. So when you convert 5 days, let me say, so you're going to say Q is equal to, if the initial amount is 10, and then E, maybe K often they'll give you, maybe let's say it is 2, and T after a certain time, maybe 5 days, and then you simplify. Now this is not how you're going to be answering the question, but the questions are going to be requiring you to use this concept. Okay, I think these are the most important things that you need to know, and see you in the next lesson as I begin solving the questions. Hey guys, so let's now look at this question involving the application of the exponentials. So the question says that the number of units N of electricity used by a household after 3 months is given by this formula here, where K is constant. Find the value of K if 270 units were used by the household at the end of the month. At the end of 1 month. So as you can see, this time T is representing what? Months. Like I said, that sometimes it will be representing the years, months, so you don't have to be confused. So if they have said that T month is given, don't convert months to days or seconds or years. No, just get it the way it is. If they are giving you 1 month, just plug the months in the where is T. Okay. And then the second one is saying that find in simplified form the exact value of the number of units used by the household at the end of 3 months, and they have said that don't leave your answer in exponential form. So they want you to simplify by applying the principles of logs and exponentials. So let's face solve the first question. So they want you to find the value of K, this one here, if 270 units were used. So they have given you the units. So where is n? Put what? Units. Okay, because n is representing the units, and it used by the household at the end of 1 month. And what is t? Time. Put 1 there. Don't convert to seconds, years, and blah blah. No. If they have said t in years, just plug it in the question here. They put in years. Just plug it directly the same way it is in years. Okay. Most of the students get confused here. They screw up. But lectures, some lectures are fair enough. They'll still mark you. They'll understand. Okay. They'll still mark you. But if they are strict enough, like my lecture would mark. Yeah. Initially he was marking wrong till he started marking. I remember this kind of question when they came. So it will just depend with the mood of the lecture. Yeah. So let's solve the first question. But don't convert, just plug it directly. Okay. So I'll just put 1 there. If it was in years and they give me 1 year, I'll plug 1 here. Don't convert. I repeat, don't convert. So now let's solve. Let's put everything into action. So we have n is equal to 30, 1 plus EKT. So I think for this n we put 270, right? And we have 30 here, 1 plus EK. Where is t? I'll put 1. So I have 270 is equal to, this time I'll divide through. So listen, before you start, don't multiply directly. If there is a number a, divide whatever is here into this. Okay, divide this into this. Don't start multiplying. So here I'll just remain with k over 30 over 30. So when you divide this into this, you're going to have 27 . So that will be 3 into 27. It is going to be 9. 9 is equal to 1 plus EK. So basically I just have 1 plus k. I can take this on the other side. I'm going to have 9 minus 1, right? And I'm going to have 8, the exponential k. So here we need k. So I'll introduce natural logs on both sides. I'll have natural log ek. So here, this one should drop because here is like I have this one. Okay, look, it's like I have first of all, let me get rid of it. I write it here. It's more like I have log e, then ek whenever I see this. So I can just drop this one here, right? So this one is going to come here. So I'm going to have natural log 8 is equal to k natural log e. So this is going to give me 1. I said it because this we are going to remain with log e, and whenever this and this are equal, this whole thing becomes 1. Okay, so let's now say natural log 8 is equal to k. So basically constant is equal to natural log 8. Makes sense, right? Let's look at the second question. So for the second one now, they're saying that find the simplified form, the exact value of the number of units used by the household at the end of 3 months. They have said 3 months. So look, they want you to find n, but where k is what you have found, okay, and t is 3 because they have said 3 months. 30, there is already numbers here, so we'll only be able to find n, right? And they don't want you to leave it in natural log this and that. They want you to simplify by applying the properties. So let's see how we can solve that. Let's solve. So we have n is equal to 30. 1. Let me check. Okay, that is n is equal to 30 plus EKT. So we're going to have n is equal to 30, 1 plus e. K is natural log 8, right? And t, time, there will be 3. So now, how can we simplify this? Because we have natural log, and there's no way you can find this one without using a calculator. So we're going to apply the properties. So there is this property that whenever you have, first let me get this part, okay, because the secret of answering this question is only at this part in. Once you understand how to deal with this part, then you have gotten the whole question correct. So here I have natural log 8. It is being multiplied with what? With 3. Okay. So whenever you have natural log, I say that it's more like you have log e, right? And then there is yeah, so in this case there is 8. Makes sense, right? There is 8e. So here is e. Now there is a property that states that, let's say you have a log a, then here is b. Whenever the base is being raised to a log or a natural log that is having anything here or a number that is equal to the base, whenever these are the same, the whole thing gets replaced by b. So whenever you have this case, the final answer is going to be b. This is another property which they don't really talk about, the majority of the educators, but for this question you need to know this property. So whenever you have a base raised to the power of log, and that log is having a base that is equal to the initial base, the final answer is this one here. So the final answer is b. So meaning that, let's say you have log 2, here is 2 raised to the power of log 2, and there is 3. The final answer is 3. Makes sense, right? And anything that is in this manner, the final answer will be this one. So here the final answer will be what? 8. So meaning that here where this e, I'll do this. I'll take this part, this one, I'll under it alone. Okay, I'll under it alone. So this part itself, this is giving me 8. So meaning that I'm finally going to have n is equal to 30 plus 1 plus, here I'll put 8. This one will remain an exponent, so it will be raised to the power of 3. So n is equal to 30 times 1 plus 8 raised to the power of 3. I know maybe you might be surprised by, confused by this property. It's just that it's rarely taught because it is rarely applied again. You'll be only, especially at your level, this is the only case where you'll be found having to apply this concept. You'll be rarely applying it. So for the sake of this question, learn how to use that property. And they like bringing this question so that they can see if you know how to apply that property. So let's say 8 raised to the power of 3, that would be 512. To be 512. N is equal to 30 times 1, 30. 30 times 512. So 30 times 512. That will be okay, to give us these figures here. Then when you add 30, you're going to get 15,390 units. Have you seen? This is how you can solve without having to use a calculator. Makes sense, right? Let's move on to, let's look at another question actually. Okay guys, so let's look at this question. The question is saying that the sales S of a new product after it has been on the market for 2 years, so this time T is in years. If they give you a figure, don't convert into months, no. Just plug it in directly. Is this formula. So the products are being represented by this formula, and they're saying that find S as a function of T if 5,000 units have been sold after 1 year. I'm using the indirect way of asking you to find the constant. they've just like twisted the English here. But all you need to see is that they have already given you the units, so 5,000 will be here. Because these are the number of product. The units in business, when you hear the word units have been sold, they are talking about the product, the number of products that have been sold. Okay, and 5,000 you have to plug it here. 1 year at where there is T, there is going to be 1. Then we solve. That's what they want you to do. Don't let them confuse with the English. These are this business studies related English. Don't let them confuse you. Let's just answer the